Hi again, everybody. Welcome back to our course in college algebra. Dr. Tom McNamara here to talk about polynomials. So in this first video, we are going to focus on identifying polynomials. So after the video ends, you should be able to look at a function or an expression and make a yes or no decision as to whether it is a polynomial. If it is a polynomial, you should be able to determine the degree and also be able to find the lead coefficient. So, you probably know this already, but a polynomial is a sum of non-negative whole number powers of x. Okay? It's a sum of non-negative whole number powers of x. So this expression right here, this is a polynomial. And I thought you said positive whole numbers, and here's negative a half. I did. I said positive whole number powers of x. Negative 1/2 is the coefficient. Coefficients can be anything. They can be whole numbers, they can be negatives, they can be fractions, they can be irrational numbers as well. Okay? So there are no restrictions on the coefficients, it's the powers. This has a power of 2. This has a power of 1. This has a power of 0. There are 0 x's, and 0 is a non-negative whole number. So this is a polynomial. The degree of this polynomial is 2. The degree of a polynomial is the highest power that you see when the polynomial is expanded. Now sometimes we write it with the powers in descending order, but there's no hard and fast rule about that. Okay, addition is commutative, so you can switch around the order in which you add things and get the same result. So it's not always going to be first. Sometimes it might be in the middle, sometimes it might be on the end. So this is degree 2, and the lead coefficient is 1. Once again, you got to be a little bit careful when you're finding your lead coefficient. Make sure you scan all the terms. The lead coefficient is the coefficient of the highest power of x. So here the highest power of x is 2. It's degree 2. What's the coefficient of this term? The coefficient here is 1. So this is degree 2, lead coefficient 1. This function here, this expression, in example 2 is not a polynomial. Now you might say, well, I thought you just said positive whole number powers. I see x squared, I see x to the first, and I see a constant. Those are positive whole number powers. But for a polynomial, you can't have x's in the denominator. Okay? You're not allowed to have variables downstairs like that. You're allowed to have fractional coefficients in a polynomial, but remember, coefficients don't have the variable. That's the numerical part. Okay? So that is not a polynomial. No variables allowed in the denominator. Now this is a polynomial here in number 3. Okay, this polynomial was given to us in factored form. This polynomial was expanded out. Can't see the factors. This polynomial is factored, so that makes it sometimes a little tricky to get the degree. The degree of this polynomial is actually 4. You might say, well, Dr. Mack, you just said the degree of a polynomial is the highest power that I can see. And I see a 2. So that's the highest power, so it's degree 2. But that's when the polynomial is expanded like this. When the polynomial is factored, you gotta account for multiplying it out. Now, I seriously discourage you from multiplying this out. If you are given a polynomial in factored form in this class, please leave it factored. It'll make your life much easier. But let me just do a quick little example of something like this. Okay, let's say I had this expression. I'm claiming this is a polynomial of degree 4, just like this one is up here. Let me show you why. If I take those two binomials and multiply them out, x squared minus 3x plus x is minus 2x. So I get x squared minus 2x minus 3. And then when I multiply in the x squared, I get x power 4 minus 2x power 3 minus 3x power 2. Lo and behold, if we multiply it out, the degree is 4. So if your polynomial is factored, you need to add the degrees that you're seeing in each of the factors. Notice we did not do that here. You only add if the polynomial is factored. And we can see here the leading coefficient would be 1, very similar to what we're seeing right here. Okay. This last example is also not a polynomial. Okay? No roots. No roots allowed in a polynomial. No absolute value allowed in a polynomial. Okay, so when you're looking at an expression and you're trying to figure out, is it a polynomial or not? You're thinking, okay, is it a sum of non-negative whole number powers? Or could I write it as a sum of non-negative whole number powers if I multiplied everything out? So, if you see fractions with variables downstairs, if you see roots, if you see absolute values, then not a polynomial. And remember, if you see a polynomial that's factored, please leave it like that. It'll make everything we do down the road much easier. Okay? So first step in working with these polynomials is be able to tell whether what you're looking at is a polynomial or not. Okay? So we have a little checklist that we can go through there.